Today, we will be presenting on how to solve the area of a function using different rules. For today's presentation, we will be discussing three rules. We have the Trapezoidal Rule, the Simpson's 1/3 Rule, and the Simpson's 3/8 Rule. Each rule will be discussed by every members of the group. For the first part of this presentation, where we will get the area of the function, I, Jana Marie Mendoza, will discuss about the trapezoidal rule. So, finding the area of a function using a trapezoidal rule. In calculus, trapezoidal rule is one of the most important integration rules. The name trapezoidal is because when the area under the curve is evaluated, then the total area is divided into small trapezoids instead of rectangles. This rule is used for approximating the definite integrals, where it uses the linear approximations of the functions. Trapezoidal rule is a rule that evaluates the area under the curves by dividing the total area into smaller trapezoids rather than using rectangles. This integration works by approximating the region under the graph of a function as a trapezoid, and it calculates the area. This rule takes the average of the left and the right sum. The trapezoidal rule does not give accurate value as Simpson's rule when the underlying function is smooth. It is because Simpson's rule uses the quadratic approximation instead of a linear approximation. Both Simpson's rule and trapezoidal rule give the approximation value, but Simpson's rule result is even more accurate. While in the trapezoidal rule, we give the approximation value of the integrals. So for today's agenda, using the trapezoidal rule, find the area of f of x equals 3102 over 2 plus x squared using any programming application of your choice. So for this rule, we will be using the Python programming as the programming application in getting the area of the f of x equals 3102 over 2 plus x squared. But first, we will try to solve the given function by manually computing it. So the given equation is finding the area of the function f of x equals 3102 over 2 plus x squared from 0 to 1. Then, we will rewrite it as f of x equals the integration of 3102 over 2 plus x squared dx with a lower limit of 0 and an upper limit of 1. Therefore, we could say that a equals 0, which is the lower limit, then b equals 1, which is the upper limit, and n, which represents the number of subintervals or the area involved that is divided up into a number of parallel strips of equal width. We could say that the value of n equals 4, for instance. Writing the formula of the trapezoidal, whereas t equals 1/2 h times f of x1 plus f of x2, then h, or the height, is equals to the b minus a over n, or the upper limit minus lower limit, then divided by the number of subintervals. Then h is equals to 1 minus 0 divided by 4, and it would give us an h of 1/4 or 0.25. Getting the value of x and f of x to solve the area of a function using trapezoidal rule, we will get the x by increasing the height of lower limit by 0.25 since it is the calculated height or gap, till it reaches the upper limit of 1. Then x will equals to 0, then 0.25, then 0.50, then 0.75, and then 1. For the f of x, we could see that the function is equals to f of x equals 3102 over 2 plus x squared. So what we're gonna do is just substitute the x in the equation to get the value of f of x. Therefore, when x equals 0, f of x is equals to 1551. When x is equals to 0.25, f of x is equals to 1504. When x is equals to 0.50, f of x is equals to 1378.6667. When x is equals to 0.75, f of x is equals to 1210.5365. And when x is equals to 1, f of x is equals to 1034. Now, the x of 0 will be labeled as f of x0, then x equals 0.25 will be labeled as fx1, x equals 0.50 will be fx2, x equals 0.75 will be fx3, and x equals 1 will be fxn. Then, rewriting the formula for the trapezoidal, we have t equals 1/2 h times f of x 0 plus f of xn plus 2 times f of x1 plus f of x2 plus f of x3. Substituting the values of h and f of x, we have t equals 0.25 over 2 multiplied to the 1,551 plus 1,034 plus 2 times 1,504 plus 1,378.6667 plus 1,210.5365. We will get the approximate area of the function by trapezoidal rule, which is equals to 1,346.4258. After manually computing the area of a function using trapezoidal rule, we will now proceed to the programming application, which is the Python. So for the trapezoidal rule, we will first define the function f of x. We will have def f of x, then return inserting the function f of x equals 3,102 over 2 plus x times x since it is x squared. Then we will have a, which is the lower limit, is equals to float, open and close parenthesis input, open and close parenthesis lower limit equals. Then b, which is the upper limit, will be equals float, open and close parenthesis input, open and close parenthesis the upper limit equals. Then for n, which is the number of subintervals or the number of strips, then that means that n is an integer, which is n equals int, open and close parenthesis input, open and close parenthesis number of strips equals. Then for h, we will just insert the formula, which is b minus a over n. Then we have a k equals 1 and a sum of 0. While k is less than n, t should be equals a plus k times h. Then its sum is equals to sum plus f of t, whereas k is equals k plus 1. Then, inserting the formula of the trapezoidal rule, which is represented by int underscore a, is equals to h over 2 multiplied by f of a plus f of b plus 2 times sum. Then we print the value of integration, which is print, open and close parenthesis, value of integration equals int a. Then, before running the code, we will first save the file and have its file name, which is group number 8 Mendoza Trapezoidal Rule. After saving the file, we could now run the program. As we can see from the result, we can see that the manually computed area, which is equals to 1,346.4258, is the same with the area of the trapezoidal rule calculated by coding, which is also a 1,346.42581300 and so on. Then, if we run the program again and change the number of strips into a higher value than 4, we will also see that the area of the function f of x is equals to 3,102 over 2 plus x squared will also get higher. For the next rule, which is the Simpson's 1/3 rule, it will be presented by Mr. Jeffrey Banog and Mr. Ed Conkle.
Hello everyone, I am Ede Comple, and for today's video, I will be showing you my sample code of Simpson's 1/3 rule using Python programming software. So let's first define the Simpson's 1/3 rule.
Simpson's 1/3 rule is an extension of the trapezoidal rule in which the integrand is approximated by a second-order polynomial. This rule can be derived from the various way using Newton's divided difference polynomial, Lagrange polynomial, and the method of coefficients.
So now let's proceed to my created code. So here is the code. So for example, we are in an electrical application, and here we can consider the function as a current and a square of voltage. So we have the equation of the current as 3102 all over the quantity of 2 plus x squared. So 3102 all over 2 plus x squared will be our f of x. So f of x, let's say the current in a certain circuit. So here, this is a function when we are going to integrate with the help of Simpson's 1/3 rule. Next is, we have this input section. So the lower limit equals the float input and then the text, which is enter lower limit of integration. Then upper limit equals float input, enter upper limit of integration, and equals int for integer input, enter number of subintervals. And then we have the calculation of step size. So we have the formula, which is h is equal to upper limit minus lower limit all over n. N corresponds to subintervals. After that, we are now implementing the Simpson's 1/3 rule. We need to define Simpson's 1/3, then lower limit and upper limit, where s is equal to 0, t is equal to 0. For I in range 1 and n, in this part, we will need to have the if and else statement, which is if I %2 is equal to the operator 1, where x is equal to lower limit plus I times h, and s is equal to s plus f of x. Else, x is equal to lower limit plus I times h, and t is equal to t plus f of x. So last is for the integration. So in this part, we have the formula, which is integral is equal to h divided by 3 times the quantity of f times lower limit plus f times upper limit plus 4 times s plus 2 times t. And then we're gonna print the integral is %.9f integral Simpson 1/3 lower limit upper limit. So as you can see, I put 0.9f in this part just to indicate the number of digits to be calculated. So in my case, the expected number of digits after decimal is 9 digits. Then after that, we are now going to this code. As you can see, we need to enter lower limit of integration. So let's say the lower limit is 0. Then enter. Enter upper limit of integration. So let's say 1. Then enter. Enter number of subintervals. So let's say for example 5. So as you can see, we have now the integral is 1226.4080152.136. And now we have calculated the integral, and as you can notice that digits, the number of digits after the decimal is 9 digits, as we have indicated in this part. And that's it. This is the Simpson 1/3 rule.
For the last part of this presentation, we have the last rule, which is the Simpson's 3/8 rule, and it will be presented by Ms. Marinela Aguilar and Mr. Leonard Barreto.
We all know that the Simpson's rule is named after Thomas Simpson, which is it is a numerical integration that refers to the approximation for definite integrals. In the simplest terms, it can be said that Simpson's rule is a numerical method that can be used to evaluate a definite integral. In most cases, when we wish to find a definite integral, then that person uses the fundamental theorem of calculus. In that case, the antiderivative technique of integration is applied. According to various sources, Simpson's rule can be used for approximating the integrals. This is done by using quadratic polynomials. Here, the parabolic arcs are present in place of straight line segments that were used in the trapezoidal rule. We have two kinds of Simpson's rule. First is the Simpson's 1/3 rule, which discussed earlier, and the second one is the Simpson's 3/8 rule. The Simpson's 3/8 rule is another method that can be used for numerical integration. This numerical method is entirely based on the cubic interpolation instead of the quadratic interpolation. This rule can be more efficient and accurate than the standard method. This is because of the fact that this rule uses one more functional value. One should note that for the Simpson's 3/8 rule, there is also a composite Simpson's 3/8 rule. The latter is more similar to the generalized form. The Simpson's 3/8 rule is also known as the Simpson's second rule of integration. So for the next part, we are going to discuss or make a sample iteration for this kind of Newton's integration.
Presenting the Simpson 3/8 rule using Python. Putting 3/1 auto over 2 plus x squared. For input section, we are using lower limit, upper limit, and sub-interval. Let's try to run it. Lower limit equals to 0. Upper limit equals to 1. Number of sub-intervals 6. The result is 1350.02. Let's try it with sub-interval of 5. The result is 1320.66. Last attempt, let's use 7 as sub-interval. The result is 1311.34.
And that's it for our group's presentation. Hope you learned something. Thank you for watching.